Hello YouTube. Have you ever wanted to turn your Python scripts into command line tools that didn't require you to preface them with Python and the name of your script? Well, in this tutorial, I'm going to show you how you can turn those scripts into Python packages with a tool called Python Poetry, and then install them on your user account with a tool called pipx, so that you can easily turn those scripts into command line tools without much extra work. So the first thing that we're going to do is install Homebrew, which is a package manager for macOS. This lets us install a lot of command line applications in an easily maintainable format. So all we need to do is go to this website, brew.sh, and then copy this command and paste it directly onto our terminal and run it. And the first time that this installation runs, it will need administrator access, so we can give it by putting in our password. And you'll see that the reason why it needs sudo access is because it's modifying /user/local, and we just hit enter and it will start installing. All right, now that Brew has been installed, the next thing that we're going to do is install a tool called pipx. So as you might already know, pip is the Python package installer, which we can use to install a lot of useful Python libraries. But a lot of times people also write useful command line tools in Python and they want to distribute them. But the way that we typically do this is by using some sort of conda environment and just doing pip install of that command line tool. But this isn't great if we switch virtual environments. And so pipx is a command line tool which basically creates a virtual environment for every Python command line tool that we install and automatically switches to it when we run those Python command line tools. And so for Mac, it's very simple to install pipx. We just need to type brew install pipx. Now that Brew has finished installing pipx, we run the second command to make sure that pipx is in our path. So we type pipx ensure path. You'll see that it added the location where pipx is installed to our path environment. And we can also install the command line completions. So we type pipx completions. And it will tell us how to do it. So macOS default is to use ZSH. So we'll have to modify our Z shell configuration file, which is .zshrc, and at the end we can just add the commands that it tells us to add. Like source to reload our configuration file, and pipx. And we see that when we hit tab, pipx has its command line completions. So the next tool that we're going to install is called Poetry. So Python Poetry is a packaging and dependency management tool. And what Poetry lets us do is we specify what dependencies our project uses. And when we do a pip install with a project managed by Poetry, it can automatically determine those dependencies without us needing to write up our own setup tool script or the traditional ways of doing Python packaging. And so this is really convenient for us. So Poetry, they do give you on their website a official installer, but this actually is kind of problematic to use because it uses a script from online and it's not something that you can really control after you've installed it. So we're going to go with pipx instead. So we'll go with pipx install Poetry, and it will just install the latest version of Poetry, which is usually fine unless you need a specific version for whatever reason. And it will slowly install. Great. So now that we have Poetry installed, we can go ahead and start writing some code. And so for a practical example, we're going to be taking a task from my background in computational and synthetic biology, which is looking up an amino acid on a codon table. So amino acids are the building blocks of proteins, which are the main molecules in body that perform most of the functions inside your body. And those proteins or amino acids are encoded inside your DNA. So the mapping between a 3-letter DNA code and the amino acid is called the codon table, which is usually depicted in a grid like this. So we can see that we have an amino acid called serine, and it has a 3-letter abbreviation SER, and there are actually 6 3-letter DNA sequences that code for a serine inside our body. And so a lot of times we'll know that we want to code for serine, but we want to pick the best of these 6 codons for that. And so we'll have to look up which which DNA sequences code for serine in this codon table. It would be nice if we could just go in our terminal and just type codon SER, and it would give us the 6 codons that code for serine, instead of having to search Google for codon table, find one that has the information presented in a usable way, and then actually scan through to look for the 6 codes, the 6 codons for serine. So a command line tool like this would speed up the process a lot. Now that it's clear what kind of tool we're trying to write, we can get started coding. So we're going to follow the documentation on Python Poetry, which tells us to create a new project using the poetry new command. Poetry new codon table. This will create a project folder called codon table, and within it, it'll create a Python package called codon_table. We'll open up this folder in VS Code, and we can look at this PyProject toml file. So this file describes not only the basics of our the Python package that we're writing, but also all the dependencies that this package uses, as well as you'll see it will actually describe what the command line scripts are in this file. So first, let's write a function, a boilerplate function, so that we can test the command line tool before we actually start writing any functionality. So here we'll create a new module within our package called, we can call it translate. And what this will do is we'll write a function called get codons for amino acid. And this is actually where we'll install a dependency called click. So click is a Python package that makes it really easy to turn functions like this into command line scripts without us needing to write extra code. So we'll go ahead and add it as a dependency using poetry add. I use click. It'll install the latest version of click for us. And now inside our translate.py, we can import click. We'll turn this function into a command line script using click.command. And then we'll specify using click.argument a positional argument, which will encode for the amino acid that the user needs to pass into this function. This positional argument is required, so we'll give it required if it's true as well. Now we'll also use, what we could do is we could use print to print out what the user passed in. So print amino acid. But what we'll actually do instead is we'll use a click function called click.echo, which if we would like, so click.echo is cross-platform, makes our prints, it checks for potential cross-platform issues. It also lets us output colored text if we would like to do that. But we'll just use click.echo for best practices. So now that we have this, we can tell Poetry that we have a new command line script that we would like to install. So we type tool poetry.scripts. And within this, we basically write that we have a new tool that we want to write, or a new script. We can call it codon. And when we run this codon command on the command line, it should actually call a particular function in our Python package. So the function that we wanted to call it's codon table.translate, and it's get codons for amino acid. So now that we've described what the command line tool is to Poetry, if we type poetry install, this will install all the dependencies, but it will also install our Python package in development mode, which means that when we make changes, it will automatically reflect those changes without us needing to Poetry install it again. But regardless, what this means is that the command line tool should now be installed. So we can test whether or not it worked by typing codon. And we can first see. So this is, we have to do poetry run codon first, because we haven't actually installed, this package is only installed within Poetry. It's not installed using pip globally. And what we'll see later on is that we're actually going to use pipx to install our package, this codon table package, which will then let us just type codon at the command line. So if we type poetry run codon, we'll see that it's asking us that we didn't provide a required argument called amino acid. So we can specify what amino acid we're looking for. So it's serine, SER. And we'll see that it goes back or prints that we passed in the argument serine. So now that we verify that we can just type a command on our terminal and it will run this function instead of us needing to specify the Python file that we want, the Python script that we want to run, I went ahead and filled in the function to give it its real purpose. And all I did was I found a codon table that was written for us by two users, so Juanfall and mball88. And what it does is these codon tables translate an amino acid, the one-letter abbreviation of the amino acid, to all the codons that encode it. And I took that, and because the one-letter abbreviations are hard to remember, I've turned them into their three-letter abbreviations, as well as stop, which is 4 letters. And then the function is very simple. It just goes ahead, converts the user's input into uppercase, which matches all these keys in the dictionary, checks to make sure whether or not it is inside our codon table. If it is, it prints out the codons that are spaced by a comma and a space, and otherwise it tells the user that we don't recognize the amino acid that they asked for. This is actually something that I just learned, is you don't use return, use sys.exit for error codes. So no sys.exit means that the command ran correctly, but we can give it an error code if the function didn't return successfully. So this will, anything that's non-zero is basically an error. So we'll return a 1. And at the top, we just need to import the sys library, which is part of the Python standard library. All right, so now that we've done that, we can test it out. So poetry run codon for something that we know, which is a valid amino acid like serine. It tells us that we asked for serine and it has 6 codons. Now let's try this with codon that doesn't exist. And basically the amino acid is not recognized. And now for the final step, we are going to install this Python package that we wrote. We're going to install it globally on our user's account using pipx, which means that instead of having to type poetry run codon serine, we can just type codon serine, and that will run our script for us. And it's very simple since we already have pipx installed. To install from a directory, so this directory, we can just simply type pipx install dot means the current directory, and this will pipx will recognize that our directory is a Python package project, and it will install it for us. See, so it's determined the package name. It's created a virtual environment. And now pipx has our package called codon table installed. And we'll see that it has what pipx calls an app, but basically it's a script, the script that we wrote here. And it's globally available. Now it's called codon. So we can actually leave this folder. So just in our home directory. We're in our home directory. We can type codon serine, and it works. We can even open a new terminal to just make sure. Type codon something. What are the stop codons? Oh, there are 3 stop codons. Codon something that's not a valid codon, and that or not a valid amino acid. And there we go. We see that it works without us needing to type poetry run.